Hey, it's Miss Gail again. Listen, chapter 17 and 18, and we're almost through. Are y'all excited? It's not going to be hard. Just stay with me. This is the purpose of dimensional analysis, is so y'all can work all these problems. We're going to talk about critical care dosage calculations. Critical care is a nursing specialty that focuses on the care of the patients who require close monitoring. How many times have we heard in the last few weeks about critical care nursing and ICUs? So get that. It's a very important role that critical care nurses play. Critical care drugs, and I'm just looking over page 345 with y'all. Are administered intravenously, should be infused with a programmable infusion pump that allows the nurse to enter the name, dosage, and concentration. This is the second paragraph of medication. If one is not available, then we can infuse it by a microdrip tubing, 60 drops per milliliter. Now, in the situation that we're in our country, we could very well see some of these microdrip tubing. So we need to know how to do this. Um, and also, in a volume control set, a safety device that can limit the amount of fluid available for infusion as last resort. However, manual infusion of critical care medication should be initiated only under the most dire circumstances. So look, let's do some thinking right now. That could be used today, well, pretty soon if we keep going with a lot of sickness in our country. Um, so we will go through that. Also, it says administer routine IVs. IV piggyback medications involves computing a flow rate to either milliliters per hour using an electronic infusion device or drops per minute. Back in the day when I started, we did a lot drops per minute. We stood there and we had to count the drops. I mean, that kind of thing. It was pretty tedious, but that is a part of nursing that you should not forget because you don't ever know when we're going to get in a situation. We're going to go back to that. So let's start about calculating milliliters per hour, infusion rates from milligrams per minute and micrograms per minute dosages. So let's just look at that first um, problem together and let's talk about this a minute. A provider orders Norpace to be infused. Norpace is a heart drug. Uh, infused at a rate of 0.4 milligrams per minute. The pharmacy supplies the medication in an IV bag containing 250 milligrams and 500 milliliters. Calculate the desired infusion rate of milliliters per hour. Round the answer to the nearest tenth of a milliliter. So what are we going to round to? Tenth of a milliliter. So keep that in mind. That is always important in working these problems. Um, so we're going to set up using dimensional analysis for the first set of given them quantities, the amount of medication contained in the IV bag. So we're looking for milliliters per hour. So where do we see milliliters per hour? We see 500 milliliters and 250 milligrams. Do y'all see that in the problem? So that's like the second line of the problem. IV bag contained 250 milligrams and 500 milliliters. Because we're looking for milliliters, we want to start with milliliters. 500 milligrams per 250 milligrams. Then our problem also tells us that we're going to go to milligrams. So it's 0.4 milligrams per minute. And then we're going to convert, what does it say, to milliliters per hour, right? So what are we going to have to do next? So if we put 0.4 milligrams per 1 minute, and that's what our problem says, then we're to go to hour, we're going to have to do 60 minutes to 1 hour. And then when we do 60 minutes to 1 hour, then we've got it all worked and we can X everything out. So we're going to be left with milliliters per hour. If you're following along on 347, work it all out, it comes out to 48 mils per hour. Pretty easy, right? If you just know what you're looking for and know how you're following. I'm not going to work those other ones with you because I know you're kind of getting bored, but I want you to go back and look at those. Also, there's some problems on 348. If you are struggling, I want you to do every other one of these and then look in the back and make sure you get them right. It's the only way you're going to learn it. Calculated milliliters per hour infusion rates from milligrams to kilogram per minute. That's on page 348, and micrograms per kilogram per minute. So let's just read some critical care medication needed to be titrated based on the patient's weight. So that's what we're doing right now. These drugs are all kind of weight related. You don't want to give too much. You don't want to give too little. You want to give the appropriate amount for what the patient weighs. So that's why we have to do all this. It's just not a set dose for everybody. A provider orders methylprednisolone, which is Solumedrol, 0.05 milligrams kilograms per minute for a patient who weighs 67 kilograms. The infusion bag contains 200 milligrams of methylprednisolone, which is Solumedrol, and 100 mils of D5W. Calculate milliliters per hour infusion rate, round to the nearest tenth. So what are we looking for? Again, we're looking for milliliters per hour. So where in our problem do we see milliliters? We see 100 milliliters. We see 200 milligrams of methylprednisolone or solumeter and 100 milliliters. So we start with 100 milliliters to 200 milligrams. Where are we going next? We're going to milligrams. Always we have to follow along. So if you're following, you know from 100 milliliters to 200 milligrams. Our next thing we're going to times the milligrams. So it's 0.05 milligrams per kilogram per minute. And then what is our we need to do our minute. So it's 60 minutes to 1 hour times what? 67 kilograms. Pretty simple. If you just follow this alone and think about what you're doing, it's not that hard. It sounds very difficult, but it really is not that hard. You just have to think through the steps and you have to work these out. If you don't work them out, I can't help you. You have to constantly be working them out and figuring out what is what and what step you're going to go to. Does that make sense to you? I hope it does. I'm here for y'all, but I just need y'all to work it out on your own too. And let's talk about it. Um, our book is excellent for figuring these out. So therefore, you work it all out. Times 67 kilograms is going to give us 100.5 milliliters per hour. And it said in the beginning that we can round to the nearest tenth. Now, using milliliters per hour, we don't, but our problem says round to the nearest tenth. So that's why we left it 100.5 milliliters per hour. Makes sense? Okay. So just look over that problem. Be sure that you understand it. You can cover up the work and go back over it and work it. That's how you learn them. Is how thinking your process through. Okay. There's another problem that's very similar. Um, Again, and also there's practice problems there. So take those practice problems, refer to the back 365 page, and they will all be worked for you. Again, this is a good way for y'all to learn it. Calculator milligrams per minute and micrograms per minute, dosages from milliliter per hour infusion rates. Just a little different thing that we have to follow. So let's read our first problem. A nurse walks into a patient's room and sees an IV infusion of lidocaine infusing at a rate of 15 mils per hour. The IV bag contains 500 milligrams of lidocaine in 500 mils. Calculate milligrams per minute dosage that is infusion. Round the answer to the nearest hundredth of milligram. So we're looking for milligrams per mil. So where in our problem we see milligrams, and we start with milligrams. That's what we're looking for. We're looking for milligrams per minute. So our top is milligrams. So we look in our problem for milligrams. 500 milligrams to 500 mils times 15 mils per 1 hour. And then we have to do, because we're looking for milligrams to minutes. So we have to convert what? We have to convert that hour to 60 minutes. And so then we work it all out, and it gives us this problem down here under solve the equation number 4, or under this, section 4. 15 milligrams over 60 minutes will give us 0.25 milligrams per minute. And it says round to the nearest hundred. So that is round to the nearest hundred. Okay. All right. There is another problem that I want you to look over, and then I want you to work these problems on 353. I want y'all to work at least 3 of them. If you are struggling, I want you to work every other one. That is what you have to do to understand this. Titrating doses according to the patient's response. A provider orders this is on page 354. A provider writes an order to start a dopamine drip at 5 micrograms per kilogram per minute IV. The dopamine drip is to be titrated. I'm on 354, example 1, with 5 micrograms per kilogram per minute. Increments up to 20 micrograms per kilogram per minute to maintain the patient's blood pressure within the range ordered by the provider. Dopamine is something to maintain the blood pressure. So they will titrate this a lot, because if the blood pressure goes too high or too low, they will be raising the medicine up and down. The patient weighs 66 kilograms. The pharmacy applies the medication in a pre-mixed infusion bag containing 400 milligrams of dopamine and 250 mils of D5W. We did a lot of dopamine with our little premature babies. We were always calculating up and down on dopamine. Calculate the milliliter per hour flow rate range, the beginning flow rate, and the maximum flow rate for dopamine drip. Round the answer to the nearest tenth. So we know our answer has to be in the nearest tenth at the end. That's very important. So what are we looking for? We want to calculate the milliliter per hour flow rate. So what is that? That is our unit of measure that we are looking for, milliliter per hour. So we put that there. Then we see 250 milliliters in 400 milligrams of the dopamine. So we put that there. So we know we have milligrams. So we have to convert, because up there we see micrograms, but we do not see another microgram. So we got to convert our milligrams to micrograms to be able to finish to work this problem. So 1 milligram to 1,000 micrograms times 5 micrograms per kg per minute. And then we need to add 60 minutes to 1 hour times 66 kg. And if we work all that out and subtract it all off, exit all out like it has, then we're going to come out with 12.4 milliliters per hour. That's how our pump is to be set. Okay? That is not that hard. If y'all sit where y'all are now, y'all should be understanding this as we go through it. So I want y'all to look over example 2 by yourself. And example 4, let's see if we've changed it all. No, these are all pretty much the same. We're looking for milliliters per hour. Let's look at example 3. This is on page 355. A nurse is assuming care for a patient on a nitroglycerin drip. The nurse wants to verify the milliliters per hour flow rate has been correctly calculated by the previous nurse. That's something nurses need to do, because you are responsible for that patient. If you start giving the wrong amount of medicine, I don't care what it was set at when you took over, it is your fault. Okay? The nitroglycerin drip is currently running at 7.7 mils per hour. The nurse reads the label of the bag and notes that it contains 25 milligrams of nitroglycerin and 250 mils of D5W. Calculate the micrograms per minute dosage that is currently infusing. Round the answer to the nearest tenth. Determine whether the dosage is infusing the prescribed range of 5 to 15 micrograms per minute. So what are we looking for? The problem's kind of like it has a lot to it. We're looking for micrograms per minute, because it says calculate the micrograms per minute dosage is currently infusing. So we know micrograms per minute. So then we look at this problem. Do we see any microgram in here other than we want it to run at 5 to 15 micrograms per minute? But that's something we're going to have to determine at the end. We're not going to determine that right now. So what do we have to do? We do see milligrams. So let's convert 1,000 micrograms to 1 milligram, and then we can go to 25 milligrams over 250 mLs, because we see that it contains 25 milligrams of nitroglycerin and 250 mLs. Okay, and then we know we're going to look for mLs again. So it's currently run at 7.7 mLs per hour. And then we're going to wind up, we need minutes, not hours, micrograms per minute. So we have to convert again. We use a conversion factor and we multiply that all out, and it gives us 12.8 micrograms per minute. Now, we won't determine whether the dosage is infusing within the prescribed range of 5 to 15 micrograms per minute. Is 12.8 micrograms per minute? Huh? Okay, I'm good. I just fixed to leave. No, it's like, I'm good. Just making sure. Yeah, 12.8 micrograms per minute is within the 5 to 15 micrograms per minute. So that's what we want to do. So that is how we do those. I want y'all to keep looking at these and looking at them over and over and over until you get them in your head. Sleep on top of them. Whatever you have to do, you will learn this. All right, let's do chapter 18, and y'all, that is it. Lifespan consideration and dosage calculations. This is kind of like just repeating some stuff that we have already done, but we will go through it real quick. We are not doing anything with BSA in chapter 18, so it's not going to take me very long. Bye. You too, Susan. One of my coworkers leaving. We're all just kind of in a trying to get everything done for y'all and trying to be here for y'all as much as we can. So general considerations for children. Let me look at chapter 18 homework. The continuous growth and development of a child's body greatly affects how much medication. So we've already talked about that. That's when we figured in kilograms. If you see a problem, calculate dosage for infants and children using body weight. So let's look at page 372, example 1. A provider orders Zofran, 0.15 kilograms IV over 30 minutes prior to chemotherapy. The patient weighs 36 kilograms. Calculate the dosage milligram of Zofran to be administered round to the nearest tenth of a milligram. So set up the equation. We're looking for milligrams. So we see 0.15 milligrams per kg. That's what our problem tells us. I didn't make that up. That is in the problem, first line. Um, we want to see times 36 kg. So it gives us 5.4 milligrams. So this 30 minutes prior to chemotherapy and this problem and all that, we're just going to ignore that. That does not have anything to do with us calculating this problem. So it's 5.4 milligrams. So just look through that alert down at the bottom on 373. Certain medications are toxic to infants, such as chemotherapy drugs and certain antibiotics. You may need to round answer to the nearest hundredth, depending on what it's asking you to do, to provide the most accurate dose. So we look at an example again. It's just pretty much simple, just following through. So be sure you look over example 3. Um, We've already talked about this once, but like a dose that's received, this is on your alert on 374. A dose received every 8 hours is equal to 3 doses per day, not 8 doses per day. We've already been through that, but I just want to review that with you again. We can look at all of go through problem 4. We've already seen some problems like that. We've seen some problems like problem 5, where you have to divide in 6 divided doses. That would be divided in 6 because it doesn't say every 6 hours, it says 6 divided doses. So be sure that you read your problem well and that you know what you're doing. Now, calculate doses in body weight. That body surface we don't do, so just ignore that. Okay, that starts on page 377. Um, and volume control set there on page 382. Pediatric daily maintenance fluids needed in infants, toddlers, and children. Dimensional analysis can be used for any part of these equations. So just review through that. It's pretty simple. We already have gone through dimensional analysis. Um, you on 383, the note says you can insert a percentage instead of a fraction for the amount of fluid provider wants to be administered intravenous. That was reviewed in chapter 3. Um, so just review these problems. I don't think they will give y'all any trouble. If they do, please contact me. 386 talks about general considerations for pregnant and lactating women. Uh, Drugs used during pregnancy. During pregnancy, a woman's body undergoes many changes that can affect how medications are absorbed, distributed, metabolized, and excreted. So we have to make sure the drugs are safe for pregnancy and that they also can be safe for breastfeeding afterwards. Then we talk about general consideration for Asian adults. 65 or older represents an estimated 14.5% of the population. That's a lot of the population you will see in the hospital. So just be sure you read over that. I'm not going to really harp on a lot of that. I just want y'all to work these problems, work them. You know I'm available by text, we'll FaceTime, whatever we have to do to get y'all through this, but you have to do your part and study and work problems on your own. Thank you. Love to see y'all. Just everybody be safe. Continue all the practices that are setting forth, and we will see each other soon. Thank you.